పబ్లిక్ ఎగ్జామినేషన్లో మ్యాథ్స్ 2A క్వశ్చన్ నెంబర్ 1 మనకు కాంప్లెక్స్ నెంబర్స్ టాపిక్ నుంచి ఒక క్వశ్చన్ ఫ్రేమ్ చేస్తాడు. లెట్ us discuss the questions based on previous year's public examinations. See this question, find the square root of 7 plus 24i అని ఇచ్చాడు ఇక్కడ. Let us suppose given complex number z a plus ib that is equal to 7 plus 24i. When z is a plus ib implies you know that root over z, square root of z formula plus or minus root over mod z plus a divided by 2 plus I of root over modulus z minus a divided by 2. Using this we can find square root of 7 plus 24i. Yes, since root over mod z formula, this one where mod z is root over a square plus b square, remember. Yes, here first I am going to find modulus z value. Mod z is root over a square 49 b square 24 into 24 multiplied by 24 576 it is, and this is root over 625, that is modulus z value 25 in this case. Now from this I can write root over 7 plus 24i become, first you have to write root over modulus z value 25 plus a here 7 divided by 2 plus I of root over 25 minus 7 divided by 2 implies we get root over 7 plus 24i, that is equal to, here in the formula you have plus or minus, so put plus or minus here, plus or minus 25 plus 7 value 32 divided by 2, that is root over 16 plus or minus I root over 25 from which you have to remove 7, that is 18 by 2, that is root over 9. Implies I can write square root of given complex number plus or minus 4 plus or minus 3i. Here it is not minus sign. In the question if you have plus sign, there you have to write plus. So here you have plus sign, so that answer plus or minus 4 plus 3i. That's next question, find the complex conjugate of 3 plus 4i into 2 minus 3i is given. We know that if I is replaced by minus I, then we get conjugate of complex number. That is, if a complex number is of the form a plus ib, then its conjugate written as a minus ib. Yes, we know that conjugate of a plus ib is a minus ib. So that here let us suppose given complex number as z equal to 3 plus 4i multiplied by 2 minus 3i. Now from this I can write conjugate of z conjugate. You will get replacing I with minus I. Here 2 minus 3, I replaced by minus I, implies z conjugate written as, this is 3 minus 4i and this is 2 plus 3i, implies z conjugate equal to 3 into 2, 6, next 3 into 3, 9i, here minus 8i, minus 12 into I square, implies z conjugate written as, here I square value minus 1. Since I square is minus 1, we get here 6 plus 12, that is 18, 9i minus 8i, that is plus I. This is conjugate of given complex number. Next question, if z equal to 2 minus 3i, show that z square minus 4z plus 13 equal to 0. This is the question. Yes. Here, what I am doing, observe. Let us suppose given z 2 minus 3i. Since z equal to 2 minus 3i, we can write z minus 2 equal to minus 3i. Next, apply square on both the sides. Squaring on both the sides, then what happens, observe, z minus 2 whole square equal to minus 3i whole square, implies in the left hand side z square plus 4 minus 4z equal to minus 3 whole square value plus 9 and I square here, that is z square plus 4 minus 4z equal to 9 of minus 1. Why? Because iota whole square is minus 1. On simplification it is z square minus 4z, transfer minus 9 into the left part, then we get plus 13 equal to 0. Let us move to the next question. Here the question is z equal to cos theta comma sin theta, find z minus 1 by z is there. Since z is cos theta comma sin theta, implies I can write z as cos theta plus I sin theta. Next I am going to find 1 by z. 1 by z is 1 by cos theta plus I sin theta. Next, 1 by z rewritten as 1 by cos theta plus I sin theta. If I rationalize with cos theta minus I sin theta, what happens, observe. 1 by z become numerator cos theta minus I sin theta and denominator part, it is of the form a plus b into a minus b, so that we get a square minus b square. A square value clearly cos square theta minus b square value I square sin square. I square value minus 1, so that 1 by z become cos theta minus I sin theta divided by cos square theta plus sin square theta. So that simply we can write cos theta minus I sin theta. This is 2 and this is 1. Why? Because denominator part cos square theta plus sin square theta value equal to 1. Now the aim is to find z minus 1 by z. Now I am going to write z minus 1 by z. First one is cos theta plus I sin theta, and from this we need to remove cos theta minus I sin theta. Therefore, z minus 1 by z value become, here cosine angle gets cancelled. I sin theta plus I sin theta become 2I sin theta. This is your answer. Let us move to the next question.